Hi, in this video this series of videos we're going to be working through a GCSE paper. Please do stop the video, have a go at each of the questions, then compare your solutions. Each of the videos is going to be about 20-30 minutes or so. It should give you about an hour's worth of fairly focused revision. If you're not sure about anything, always add a comment. I'll come back to you and I'll look forward to seeing you inside the video.
Hi, this is the second video in the Foundation Tier Edexcel Paper 3 for 2017. In the previous video we completed through to question number 14. In this video we're going to start from question number 15 onwards. Okay, so here we are in question number 15, and we've got the universal set is odd numbers less than 30. What I would do with this is I would actually write these numbers out. So I'm going to write out 1, 3, 5, 7, 9, 11, 13, 15, 17, then I'm going to go 19, 21, 23. I've just got a little bit of space left at the top here, so I'm going to do 25, 27 and 29, because that will allow me then to methodically work through each of the numbers. And really what we're going to do is place them on the Venn diagram for A, B and the remaining universal set. Okay, so let's have a look at number 1. Well, it isn't a member of set A or set B, so I'm just going to put that at the top there. And then number 3 is a member of set A, and you can see that here. So I'm going to put that into 3. Okay, then I'm going to have a look at 5. Well, 5 is a member of set B, is this one over here. Okay, so I'm going to get rid of 5. I'm going to put that in set B. Okay, and then I've got 7. Well, 7 isn't a member of set A or B, so that's going to go into this group here. However, 9 is a member of set A, so I've then got 9, which I'm dealing with, and you can see 9 there. I'm going to put that in the middle of set A. Okay, there's then 11. Well, 11 again isn't a member, so it's just really a case of methodically working through each of these just to get yourself into a position where you're dealing with all of the numbers. So we've come to number 15. Now you'll see that actually number 15 is a member of set A and set B, so I'm going to put that straight in the middle there. Okay, that deals with 15. And then I've got number 17. 17 isn't a set of anything, so that's there. And then 19. Well, 19 is also not part of A or B, so I'm going to put that at the top there. And now we're on the final few numbers. So 21, well, 21 is a member of set A, that's going to sit in there, so that deals with that one. 23, that's going to be part of the universal set, so that's there. 25, well, 25 is actually a member of set B, and it's all the members of set B, so we'll put that into there. And then 27 is a member of set A, which is this one here. And then finally 29 is one that's out in the universal set. And actually that answers the question. So providing you're methodical with it and you work through steadily, I would personally write them all out as I've done there. That just makes my life a little bit easier. Okay, and then we've got a 1-mark question towards the end, and it says a number is chosen at random from the universal set. What is the probability that the number is a set of A union B? And what we mean by that is a member of these sets here. Okay, now in those sets there are actually 7 numbers, and then in total there are 15 numbers altogether. So actually the probability that it's going to be part of A or B is going to be 7 numbers out of 15 altogether, and that would be the answer to that particular question. Okay, let's move on then to a simultaneous linear equation. Now this one is okay, it's not too bad. We're getting into kind of top grade 4, sort of grade 5 territory with these sorts of questions. Basically the way to deal with this is elimination. So what we're going to do is I'm going to write 3x plus y equals minus 4, and then 3x minus 4y equals 6. And what I'm going to do is if I subtract one from the other, it means I actually lose the 3x, because 3x take away 3x means that goes. But then I've got to be a little bit careful, because I've got positive y minus 4y. So I've got two minuses together which make a plus, so that's going to be y plus 4y is going to give me 5y. And then I've got minus 4 minus 6 is going to be minus 10. Okay, I'm going to divide through by 5 and I get my first answer, which is y equals negative 2. Okay, and then it's a case really of taking that value and substituting it. And you can choose whichever of the equations you particularly want to use. I'll just choose the first one, so I'm going to have 3x plus y equals negative 4, and I know now that my value of y is going to be negative 2. Okay, so therefore if I add 2 to both sides, I'm going to get 3x equals minus 2, divide through by 3, and I get x equals negative 2 over 3. And that's the two answers to the question. So I would write them out. Obviously you can write them out on the answer at the bottom, but just for the sake of the video, I'm going to write x equals negative 2 over 3 and y equals negative 2, and that's the answer to question number 16. Okay, hopefully that's okay for you. Let's move on then to question number 17. If you're not sure about any of these questions, please do leave me a message in the comments, and I do have playlists that you'll be able to have a look at. Okay, so the table shows some information about the dress size of 25 women. Okay, so if I add all of these numbers of women together, I'm going to get 25. And then it says find the median dress size. Well, the median dress size is going to be the lady that's in the middle of the 25 women. Okay, so the way to do that, you could just imagine it in your mind's eye, I guess, and then you can work out that actually it's the 13th lady that's trying on these dresses. So therefore, the way I would do it more kind of mathematically is to write out median equals 1 plus 25. So in other words, the first person plus the 25th person divided by 2 is going to give us the 13th person. Okay, so let's be a little bit careful. When we go back to our list here, we're looking for the 13th person. If you can imagine them all stood in a straight line, this would be the first 2 people, and then with the next 9, that would be the next 11 people, and then with the next 8, that would be the first 19 people. So actually the median person is in this group, right at the beginning of this group. So we can say that the median dress size is going to be size 12. Okay, and that would be the answer to that particular question. A little bit of working for 1 mark. Okay, let's have a look then at part B, which is a little bit complex, but actually it's one of those questions, it's only 1 mark, it's one of those questions where you just got to kind of read it. The key part of this is the word or. So is Zoe correct? Well, actually no, because what we're basically saying is that some of them, so I'll just put no, some might, I have to excuse my writing, have shoe size, I think it's shoe size 7. And the important thing is, rather than or, it would be and dress size 14. Okay, so it is a bit of reading through, and you've got to kind of work through to sort of understand what Zoe is talking about. But basically, the key issue there is she said or, and really she should have said and with that. Okay, let's move on then to a ratio question. This is quite a popular sort of form of question. Worthwhile stopping the video and having a go at this particular question. So we've got 420 cakes, and there's going to be vanilla. And I'm going to give myself a bit of space here because I need to kind of work things out. Okay, lemon and chocolate. Okay, so it says 2/7 of the cakes are vanilla. So we've got 2/7 of 420 cakes. Well, that means there must be 120 vanilla. And then it says 35% of the cakes are banana. Okay, so that's fine. So let's have a look. 35%, I'll make it into a decimal. 0.35 times 420 is going to give us 147 cakes are going to be banana cakes. And then it says the ratio of the number of lemon cakes, the number of chocolate cakes is 4 to 5. Okay, well that means then that we've got to be very careful because we've got 420 cakes, but actually we're only accounting here for 9 cakes. Okay, we want a little bit more than that because so far out of our 420 we've accounted for 267 cakes, which means that if we take one away from the other, what we actually need is to account for an additional 153 cakes. Okay, so if you look at the 9 that we had originally accounted for, we need to make everything 17 times bigger. So what I need to do is multiply that by 17, and I'm going to get 85, and then multiply that by 17, and I'm going to get 68. Okay, so therefore what I know now is that lemon cakes, which is the question, number of lemon cakes that Daniel bakes, is actually going to be 68. So hopefully that's okay for you. Don't forget you've got to account for the full 420 cakes. So 68 lemon cakes. Okay. Let's move on then to question number 19. Question number 19 is angles in a polygon. Again, fairly popular type of question. It's worthwhile getting to grips with these sorts of questions. They tend to be towards the middle end of the paper. Definitely worthwhile having a go at. Okay, so show that polygon P is a hexagon. Alright, well, let's not worry about that too much. What we're going to do is concentrate first on the 12-sided polygon, and what we're going to do is work out this angle here. Because we know this is a square, this must be 90 degrees. So I'm okay with the square. I've just got to work out the internal angle for the 12-sided polygon. And the way we do that, if I just make a note that's the 12-sided polygon, there's a couple of ways. I think really probably best at this particular juncture to use the formula. So the internal angle, or the internal angles rather, is going to equal to, and the formula is n minus 2 multiplied by 180, where n is the number of sides. So therefore number of sides is 12, so 12 minus 2 times 180, well that's 10 times 180 is going to be 1800. So that's the sum total of all of the internal angles of the polygon. So what we're doing is we're adding not just B but also C and this one down here and this one, and you know, all the rest of them. There's 12 of them all together, so they all add up to 1800. So therefore if we want to find the value of each one, what we've got to do is we've got to divide by 12, and that's going to give us, each one is going to be 150 degrees. Okay, so now we know, back to our diagram, that this angle B must be 150 degrees, and the angle in the corner of the square there is 90. Now we know that the full degrees around the point is going to be 360 degrees. So therefore, if we want to work out the angle, internal angle of the polygon, which I'm going to call angle ABC, so angle ABC, and that is going to be the hexagon angle. Okay, well that's going to be equal to 360, take away 150, take away the 90 degrees of the square, and that's going to be 120 degrees. Okay, now what we've got to do is then prove that the internal angles of a hexagon are going to be equal to 120 degrees also. So I'm going to use exactly the same formula. I'm going to say I've got my hexagon. Okay, and the internal angles are going to be equal to exactly the same formula, so that's going to be n minus 2 times 180. Well, that's going to be 4 times 180 because there's 6 sides in a hexagon. That's going to be equal to 720, and therefore each angle is going to be 720 divided by 6, which is 120 degrees. Okay, so therefore it must be a hexagon. Okay, I think they've called it P, haven't they? Polygon P. And that would be the answer to that particular question. I do have some other very similar questions on a playlist and on 3-Minute Maths if you'd like to have a look at them. Okay, let's move on then to question number 20, which is all about density. Density is something that seems to be around a fair bit, really. And what we need to do with that is just learn the formula. It might actually be on the formula sheet, I'm not entirely sure. But if you learn the formula, it makes it much, much easier. It's also a very wordy question, so what I'm going to do is I'm just going to break it down a little bit, and I'm just going to look firstly at apple juice. Okay, so if I look at apple juice, what information have I got? Well, the formula is going to be density equals mass divided by volume. Okay, so with the apple juice, we're told that the density is actually 1.05, and we're also told the volume is 25 centimeters cubed of apple juice. So I can use that information to work out the mass of apple juice that we're actually going to use, or the weight of apple juice. I've got mass, and the volume is going to be 25, and the density is going to be 1.05. So if I multiply across by 25, I know now that the total mass of apple juice that's going to be used is 26.25 grams equals the mass. Okay, and that's fine. And I'm going to do exactly the same now for fruit syrup. Okay, so for fruit syrup. Okay, now I'm just in the habit of writing the same formula out. I just think it's very helpful for your thinking. It gives me space to actually think these things through as I'm doing them. So I've got 1.4 for the density, and again, you might need to just go back to the text to get that information. And the volume is going to be 15 centimeters cubed, so that's going to give us 21 grams mass of fruit syrup. Okay, so that's perfectly fine. So I've got two things there, and then the final thing I'm going to do is exactly the same for water, and all of this information is in here. The water density is 0.99, and the volume of water is 280 centimeters cubed, so that's absolutely fine. We've got density, okay, equals mass divided by volume, and therefore we've got 0.99 equals mass divided by volume of 280, cross multiplied by 280, and now I know that it's going to be 277.2 grams mass of water. And then the question is, work out the density of the drink, which is this little bit at the top here. I'll give your answer correct. Well, that's fine, because now we know that we've got a density formula again. So the drink itself, okay, yep, guess what? I'm going to write density equals mass divided by volume. You might not want to do this much, but I tend to prefer to do it. It just makes my calculations and thinking a lot easier. So how much mass have we got? Well, we've got, for the apple juice, we've got 26.25. For the fruit syrup, we've got 21 grams, and for the water, we've got 277.2, and that's all divided by 320 centimeters cubed worth of volume. And actually, if you add up the volumes of each of the drinks, you're going to get 320. So if I divide that by 320, that's going to give me a answer of 1.0139. Therefore, for two decimal places, it's 1.01 grams per centimeter cubed for the density of that particular drink. So a little bit challenging, just takes a fair bit of working through, but hopefully that will give you some idea of the kind of working you need to do with those sorts of questions. Okay, so we've got about 3 questions left. I think we'll carry on. We might as well, and we'll just have this as being a 2 video walk through. So this one is not too bad. The issue with it is the way it's been drawn, as it is with a lot of these sorts of questions. It just makes it more difficult the way they draw them, really. So what I'm going to do is I'm going to draw the smallest triangle on the left hand side and then the larger triangle on the right hand side, because it just makes it much easier for me to see. So therefore I've got a 3, 4, 5 right angle triangle, and then the larger triangle is going to be 10 at the bottom there, which is the information I need. Okay, so this is going to be 7.5, and then this is going to be 12.5. Okay, the information I need really is to work out the scale factor. Now the scale factor is, what have I multiplied 4 by to get to 10? Well, I've multiplied it by 2.5. Okay, so in order for these triangles to be mathematically similar, all the others have to have the same scale factor. So what I would do is I would look at 5. So we've got scale factor, okay, equals 2.5. So therefore 5 times 2.5 equals 12.5, which is correct. It's at the top. Okay, and then I've got 3, which is the left hand side, times 2.5, which is 7.5, and that's absolutely correct. And then of course I've got the one I worked out, which is going to be equal to 10. Okay, so therefore yes, and I just might put a note that the scale factor equals 2.5, and therefore mathematically similar. Okay, great stuff, no problem. Hopefully that's okay for you. Let's move on to the next question, which is just a simple graph question. And again, graphs are they're okay, they're fairly straightforward. On the grid below, draw the graph of values from 0.5 to 6. Well, basically you just got to work them out. You've got the calculator, so you're taking the value of x, which the first one is going to be 0.5. Okay, how many 0.5s are there in 6? Well, there's actually 12 of them. Oops. 12, okay, and then how many 1.5s are there in 6? Well, there's 4 of them, 2 of those, 1.2 of those, and 1 of those, and then really you're just plotting it. So it's a fairly straightforward final last but one question. Okay, so I've got 1, 6, which is going to go there, and then I've got 2, 3, which is going to go here. Okay, hopefully this is all right for you. You can see this okay on the screen. And then I got 4 and something like about 1.2. And then I got 5, 1, and then I got 6. I don't know, something like 6, 1 is going to be there. I think that's right. Okay, I've probably got that slightly wrong on the thing, but you'll get the idea that really what we're looking to do is to plot a nice straightforward graph, probably a little bit better than mine. You'd probably need to make sure you've got a bit of a dip going on there. Okay, all right, you get the idea hopefully, and obviously your work will be a little bit tidier than mine. Okay, let's move on. Just in the interests of time, I want to move on to the very final question. So Harley's house is a value of that, correct to 2 significant figures. This is a bit of a funny one actually, because write down the least possible value of the house. Well, the least possible value is fairly straightforward. That would be 155,000, because when I round that to 2 significant figures, I'm going to get 160,000. So I'm okay with that one. But I think the second question, you've got to be a little bit careful. The greatest possible value of the house is actually 164,999 and 99p, because it has to be less than 165,000. So just be a little bit careful. I'm not entirely sure for me personally whether that's a particularly good question, but that's the way they've asked it, and you know, we just have to go by what we've got here. So I would say it has to be less than 165,000. Got to be very careful. Okay, then it says the value of Rita's house increased by 5%. The house then had a value of 210,000. Okay, so what we're basically saying is 210,000 is equal to 105% of Rita's house value. Okay, now most mathematicians, including myself, wouldn't spend too much time writing all these sorts of things out. What we would normally do is convert that firstly to a decimal, to 1.05, and then of Rita's house value, I'm just going to write as V. Okay, so therefore to find the value of Rita's house before the increase, I divide through by 1.05, and I get 200,000, and that equals V. So the value of Rita's house before her increase was 200,000. Okay, that's the end of the paper. Hope it's been useful to you. Please do let me know in the comments if you need any help with any of the particular questions. I'll look forward to seeing you inside the next video.